Hi everyone, my name is Daniela. We're going to be talking about the philosophical thought experiment, The Chinese Room Argument by John Searle. So to begin, let's take a look at machine functionalism, the idea that mental states are defined by what they do, not by what they are made of. So according to this view, the mind is like software and the brain is the hardware. If the system performs the right functions, receiving inputs, processing them, and producing the appropriate outputs, it could, in theory, have a mind, regardless of whether it's biological or an artificial substrate. So this theory pretty much underlies much of the cognitive science and AI development today. But is it enough to explain consciousness and understanding? Enter John Searle. He challenges functionalism with a thought experiment known as the Chinese Room argument. Imagine a person locked in a room. They don't understand Chinese at all, but they have a rule book in English that tells them how to manipulate Chinese symbols to form valid responses. To someone outside, it appears as if the person understands Chinese, but inside, the person is just following rules. Searle says that just following a program doesn't equal understanding. So Searle is saying that manipulating symbols isn't the same as knowing what they mean. Computers work in pretty much the same way. They process inputs and produce outputs, but they don't understand the content. So this challenges the view. This challenges the view of some AI theorists, especially those who support strong AI, who claim that a computer running this program literally has mind and can understand. Searle's conclusion is that the distinction is between syntax and semantics. Computers and the person in the room operate syntactically. They manipulate symbols according to the rules, but they lack semantics, the understanding of what those symbols mean. Searle argues that no matter how sophisticated a program is, it would be manipulating symbols without meaning. Therefore, it truly doesn't understand. One major response to Searle is the system reply. It says, okay, maybe the person doesn't understand, but the entire system does. The person, the rule book, inputs from a larger cognitive system. So even if the person memorized the entire system and ran it in their head, they still wouldn't understand Chinese. For Searle, understanding isn't happening here. It's not in the person, not in the system. The robot reply, though, suggests putting the program into a robot that can see, move, interact with the world. The idea is that meaning arises from the embodied experience, not just symbol manipulation. Searle says that even then, the robot would still just be running a program. Then we get to my favorite argument, which is the brain simulation argument. What if we simulated an actual human brain, neuron by neuron? If the simulation behaves just like a human, wouldn't it also understand? And finally, connectionism offers an alternative. It says that intelligence doesn't come from rules, but from neural networks that learn and adapt, similar to how our brains work. So I decided to come up with some real-life examples. So the first one, again, my favorite, it's a new company that's developing a brain simulation platform called Final Spark. They're a biocomputing startup pioneering the integration of human brain cells into computing systems to create energy-efficient bioprocessors. They have an innovative approach to involving cultivating living neurons known as brain organoids and connecting them to electronic hardware to perform computational tasks. It makes me question if we can compute with live neurons, is the resulting system still a machine? Then we have the twin brain concept, which is a thought experiment where we imagine duplicating a brain exactly. Structure, function, everything. Would that brain also have a mind? Lo and behold, we have the digital twin brain simulator for real-time consciousness monitoring. It utilizes real-time data from macaque monkeys to monitor and simulate brain states. So it records signals that, and these monkeys, both awake and anesthetized conditions, simulates the signals, then the model updates the internal states in real time. So it's taking real-time neural signals from these monkeys and using machine learning to update a digital model of the brain dynamically. So it's no longer just simulating behavior, since it's moving towards personalized continuous brain simulations. We're simulating inner brain dynamics and doing so in real time. So I placed another slide here, or another video here, just for fun, about monkey mind pong. The monkey had a neural link chip implanted and records neural data or activity from the motor cortex, showing that direct brain communication is possible. No symbolic rules, just embodied intent transformed into action. So the idea is that you can simulate a brain closely enough to replicate understanding is no longer hypothetical. I mean, there's program and the monkey data, and there's models that update and self-organize using real neural input. So even the mind pong and that the monkey uses, I think functionalism still holds weight if we expand it to include embodiment and learning. I also think Searle underestimates the role of emergence, and finally, if the brain is itself a type of computation machine, why rule out the possibility that the machine could also not come to understand? I think it may be a little outdated at this point. The debate continues, but the landscape has evolved. So, can symbol manipulation ever lead to real understanding? Aren't we advanced biological processors as well? Emergence can't be dismissed. Intelligence is just the sum of computation, interaction, and adaptation. Yeah. If I do lean into us just being advanced information processors, our neurons follow electrical and chemical rules too. So where do we draw the line between processing and understanding? Like I said earlier, ignoring the role of emergence, how complexity gives rise to entirely new properties like consciousness or self-awareness. Writing off emergence is like denying the possibility that understanding could arise in the right kind of system. Ultimately, I believe intelligence isn't just about computation. It's about how a system interacts with its environment, adapts, and develops. And as Sam Harris beautifully said, our guide is the science of how our mind works. That exploration isn't over. It's just the beginning. And functionalism, with all its needed upgrades, might still be the best map we have